system whose open loop transfer function is given to us. So let's take the problem. So our problem is to sketch the polar plot for the following transfer function, and transfer function is given to us as gs equals to 1 upon 1 plus s whole square. So let's try to solve this problem. To sketch the polar plot, the first step is to put this s equals to j omega. That is, replace this s by j omega. So step number 1 will be put s equals to j omega in this equation. We are given in the question that this 1 plus s, it is of the form 1 plus st. So we need not to convert this transfer function in 1 plus st form. It is already given to us in 1 plus st form. Here t is equals to 1. So putting s equals to j omega in the expression for the transfer function, so this gs will now become gj omega, and it will be 1 upon 1 plus j omega whole square. Now second step is to find out the magnitude and angle of gj omega. So magnitude is given by, magnitude is m, and it is the magnitude of gj omega, and it will be 1 upon 1 plus, because here we are having whole square, so it will be 1 plus omega square. If whole square was not there, we will have put here under root. So this is the magnitude of the gj omega. Now phase angle. Phase angle is represented by phi, and it is phase angle of gj omega. It will be given by tan inverse of this 0 upon 1. 0 is the imaginary part and 1 is the real part. Whenever we have the expression like x plus jy, we have to find out the angle, then it will be given by tan inverse of y by x. That is imaginary part upon the real part. So when we are calculating the phase angle for the numerator and denominator, then it will be tan inverse of 0 upon y. If the expression is like tan inverse of x by y, then it is, sorry, if the number it is given to us as x by y and we want to find the phase angle, then it will be tan inverse of x minus tan inverse of y. Okay. So numerator phase angle will be tan inverse of, imaginary part is 0, real part is 1, so it will be tan inverse of 0 by 1 minus tan inverse of, here we are having 1 plus omega square, so it will be minus 2. 2 will come up before this, minus 2 tan inverse of omega. Now tan inverse of 0 upon 1 will be 0, tan inverse of 0. So phase angle, that is phi, it will be minus 2 tan inverse omega. The magnitude equation, mark it as 1 and this is as second equation. Now using these two equations, using equation 1 and 2 form a table. And in this table, the value of the omega, that is the frequency, it will be varying from 0 to infinity. And for these various values between 0 to infinity, we will find out the magnitude and the phase angle. So let's form a table here. Let's take the first value of omega as 0. So magnitude, if we put in the first equation for the magnitude as omega equals to 0, then it will be 1 upon 1 plus 0. So it will be 1. So the magnitude for omega equals to 0 is 1. Now in this phase equation, if we put omega equals to 0, then it will be minus 2 tan inverse of 0. So it will be 0 degrees. So phase angle is 0 degree. Now let's take second value of omega as 1. In the magnitude equation, if we put omega equals to 1, then it will be 1 upon 1 plus 1, that is 1 by 2. So the magnitude will be 0.5. Here if we put omega equals to 1, then it will be minus 2 tan inverse of 1. Tan inverse of 1 is what? 45 degrees. So 2 into 45, it will be 90 degrees. So it will be minus 90 degrees. Now take another value of omega as 2. So for omega equals to 2, the magnitude will be 1 upon 1 plus 2 square, that is 4. So 1 upon 1 plus 4, that is 1 upon 5. So it will be 0.2. Here if we put omega equals to 2, then minus 2 tan inverse of 2. So the phase angle, it will come out to be minus 126.8 degrees. Okay. Now let's take omega equals to 5. Here if we put 5, then 5 square is 25, 25 plus 1, 26. So 1 upon 26, the magnitude will come out to be 0.038. And phase angle minus 2 tan inverse of 5, the phase angle will be minus 157 degrees. Now the omega is varying from 0 to infinity, so the last value we will take as infinity. Putting here in the magnitude as 1 upon 1 plus infinity, so it will be 1 upon infinity, so the magnitude will be 0. And here if we put minus 2 tan inverse of infinity, so tan inverse infinity is what? 90 degrees. 2 into 90 degrees will be 180 degrees. So it will be minus 180 degrees. So for various value of omega from 0 to infinity, we have calculated the magnitude and the phase angle. Now our next step will be to plot these values on the polar coordinates. That is, we are going to plot the magnitude and the phase angle on the polar coordinates as the omega, it is varying from 0 to infinity. Okay. So let's plot the polar plot for this system. This is imaginary axis, this is real axis. So, and this is origin. This is minus 90 degrees, minus 180 degrees. Let's divide this real axis for the magnitude. We have 0, 0 0.2, 0 0.4, 0 0.6. Similarly here 0 0.2, 0 0.4, 0.6, 0.8. Then we have 1.0. So now let's plot the magnitude and the phase angle on these polar coordinates. Now magnitude, it is represented by concentric circles on the polar plot, and phase angle, it is represented by radial lines. So here for omega equals to 0, the phase angle is 0 degrees and the magnitude is 1. That is this point. Magnitude is 1, phase angle is 0 degrees. Okay. So this is for omega equals to 0. Now for omega equals to 1, the magnitude is 0.5 and the phase angle is minus 90 degrees. So minus 90 degree here and phase angle is 0.5. So this is 0.2, 0.4. So 0.5 will be somewhere here. Okay. So this is for omega equals to 1. Now for omega equals to 2, the magnitude is 0.2 and the phase angle is minus 126.8 degrees. Now the phase angle is in negative, so negative phase angle in the polar plots, it is measured clockwise. So clockwise we are going to measure it, that is in this direction. This is minus 90 degrees, so we have to plot minus 126.8. So it will be like this, minus 126.8 degrees, and the magnitude is 0.2. So it will be here, and this is for omega equals to 2. Omega equals to 2, magnitude 0.2 and phase angle is minus 126.8 degrees. Now for omega equals to 5, phase angle is minus 157 degrees and the magnitude is 0.038. So minus 157, it is plotted with the help of a protector. Make these angles, this put the protector here and this is 90, then minus 180. So make these angles and magnitude is 0.038. So it will be somewhat like here. Now join these points. We have, this is for, these are the points. And for omega equals to infinity, we are having the magnitude as 0 and phase angle is minus 180 degrees. Minus 180 degrees here and magnitude is 0. So this is for omega equals to infinity, omega equals to 5, omega equals to 2, omega equals to 1 and omega equals to 0. Join these points. When we join these points, we are getting a curve, a path, and this path is the polar plot. So polar plot is what? It is the plot of both the magnitude and the phase on the polar coordinates as the omega is varying from 0 to infinity. Okay, and this is the polar plot for the system whose open loop transfer function is 1 upon 1 plus s square. Okay, so what we do when we are given in the question that we want to plot the polar plot of a system. So for polar plot, your first step will be to put the s as j omega, that is replace this s in the transfer function by j omega and then get the expression for gj omega. Then find out the magnitude and angle of gj omega, that is m and phi. You have got two equations and using these two equations form a table, vary the value of the frequency from 0 to infinity. So for various values between this 0 to infinity, we have got the values for magnitude and the phase angle. Then plot these points on the polar plot, on the plot that is the polar coordinates. You are plotting all the points. The radial lines, they represent the phase angle and these points, they represent the magnitude. Then join these points, the curve what you are getting is the polar plot of the system. So for this transfer function, we have plot the polar plot, and I hope this problem is clear to you. Thank you.